Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syahinda binti Rahim. Okay, today we're gonna do the lab 3, AC high voltage measurement and monitoring. Okay, our lecturer is Dr. Zikri Abadi bin Baharudin, and I'm from 4BEI section 1-2. Okay, first I'm gonna introduce my group member, which is me, myself, Nushainda binti Rahim, and Muhammad Muhaimin bin Sa'ari, and Nurul Nadia binti Jamaluddin.
Okay, for the safety rule action that needs to be concerned is first use the proper glove as safety precaution when doing testing in order to avoid any charge flow into the body. And second, make sure the earthing system connect properly in the component, which is using copper braided. And before doing testing, make sure the provide double safety by using earthing rod, and for the every maintenance work must use a glove as safety rule when doing maintenance at the component.
Assalamualaikum and hi everyone. My name is Nurul Nadia binti Jamaluddin, and today I will present section number 2 for lab 3. First of all, I will present about the features and its function for Kit Control 4.0. The first features are source control. The function of source control is to increase the percentage of the graph, and another function is to increase the gain in the system. Next features is primary side of transformer progress. The function of these features is to show the voltage and current value when we activate the system, to produce the voltage and current graph sinusoidal form and show the different value between RMS and RMC. Next, the system monitoring of secondary side of the transformer with 8 slot. The 6.8 frequency converter, which is VM1, VM2, VM3, VM4, VM5 and VM6 related to this 8 slot in the system monitoring. Only VM1 and VM2 will use AC source and others will use DC source. Only VM1 and VM2 will use the AC source and others point will use DC source. So next, VM1 point at frequency converter contact with 2 slot, which is RMS and RMS1. VM2 also contact with 2 slot, which is peak over square root 2 and RMS2. For VM3, VM4, VM5 and VM6 only contact with 1 slot, which is measure 3, measure 4, measure 5 and measure 6. And the last feature is the alarm system. The function of alarm system is when the alarm button will turn to green color means that the system is in good condition. When the alarm button indicates red color means that we cannot do any injection and there is a fault in the system. Lastly, we need to reset the alarm to clear the fault or whenever we want to restart the system. Next slide, I will present about the requirement to setting the customer setup. Firstly, the serial number and the voltage divider ratio or multiplier must be checked properly to ensure that those numbers match with the manual. Next, the purpose to make sure that the value is the same with manual is to prevent any problem from happen when we need to run the system. So the serial number in the manual is 22341076-04 and the voltage divider ratio or multiplier value is 19651.1 volt. And the last step is after identifying the right value, both serial number and voltage ratio or multiplier, then we need to set those value in the customer setup. Next, for this slide, I will present about the important section of picoscope and its function. The first one is data log. The function of data log is to choose which channel will be used. Another function of data log is to make sure that the channel in software need to matching with channel at the real picoscope. Next, the data acquisition section. The function of this section is to control the number of samples for the graph. Next, to set the sample interval and trigger setting. Used to decide the graph range, activate which channel being used, choose the coupling that need to be used in the system, which is AC or DC, and the last one is to set the divider ratio or multiplier. And the last section is program control. The function is to control the system when to stop and when to start. We must click reset button whenever we want to start the system. And lastly, to observe if there is any error occur in the system. For the last slide, I will present about the step to set up the Picoscope 3000 series. Firstly, we need to set the acquisition sample or number of sampling. We need to set the number of sampling at higher value as possible because the higher the value, the better waveform will appear in the graph. Next step is to set the sampling interval to get the accuracy measurement value. The sampling interval will taken at 2 points, which is from 5 microfarad to 15 microfarad as the example. After that, we need to set the trigger setting. The purpose of set the trigger setting is to obtain the impulse in order to decide the threshold level or range. Next, we need to activate which channel that we use in the system that being connected with picoscope. For this experiment, we use channel A. There is 4 channels at picoscope, which is channel A, channel B, channel C, and the last one is channel D. Continue from the previous slide. The next step is to set up the picoscope. We need to turn on coupling signal in the system. We need to choose AC coupling. Since the coaxial cable are being connected with VM1 at frequency converter, we need to use AC coupling because it states that VM1 is only for AC source. Next, choose the range to set the amplitude range. Set the divider ratio similar with the manual, which is 19651.1 volt. Next, we set the offset at 0. Next, activate channel A at data log and choose AC. And finally, press the reset button at program control whenever we want to start the system and we can run the system as usual. So that's for me, and I will pass the next slide to the next presenter, which is Nur Syahinda binti Rahim.
Okay, for my part, I will explain section 3, which is a comparison between the result of reference from kit control and display signal from picoscope. Okay, the result, the data already given by Dr. Zikri Abadi at the ULearn, the PDF file. So we just need to construct a table of output voltage, reference of key control, display, picoscope, the area that we need to calculate it, and the frequency. Okay, as you can see on the slide there, that is the table that I already made from the data that given by Dr. Zikri. So as we can see from the table above, when the output voltage increase, the error that we get will be decreased. Okay, for a conclusion, since we only use VM1 in this experiment, so we only need to construct the comparison table between reference, kit control, and display picoscope for VRMS. We don't need to construct the table for peak square root 2 because the calibration is set only for RMS with 19651.1 volt divider ratio. Okay, the percentage of error occur due to sensitivity range of scope at the coupling setting.